Northrop White Sands in New Mexico. We have a chance of rain showers there, and that site is being ruled out as a contingency landing site at this point. Overseas at the transoceanic abort landing sites, the weather is also looking to be acceptable. Both the Morón site in Spain and Ben Guerir Airport in Morocco are showing good weather systems. However, we only need one good TAL site to launch, and there has not been a selection of the prime site at this point yet, but chances are it will either be Morón Air Base in Spain or the Ben Guerir Airport in Morocco. No significant issues being worked at this time in the firing room that would impact liftoff at 10:53. We have good weather. The astronauts are in the process of beginning their suit-up operations, and following that are scheduled to go out to the launch pad at about 7:38 this morning. In the operations and checkout building, the STS-58 flight crew are donning their flight suits in preparation for this morning's launch. Our commander is Colonel John Blaha, giving us a thumbs up and signaling that he's ready for flight today. Payload specialist is Dr. Marty Fettman. This will be the first trip in space for Dr. Fettman, who also has the distinction of becoming the first veterinarian to make a shuttle flight. Here's mission specialist Dr. David Wolf, wishing everyone a good morning and gearing up for his first flight in space. Mission specialist number 2 is Bill MacArthur. Bill is a lieutenant colonel in the Army and has served as a CAPCOM or capsule communicator in the Johnson Space Center among his duties since becoming an astronaut in 1990. This will be the first trip in space for Lieutenant Colonel MacArthur. And here's our payload commander and mission specialist number 1, Dr. Ray Seddon, giving us the AOK sign and a thumbs up. This will be the third trip in space for Dr. Seddon, who also, aside from her astronaut duties, serves as an emergency room physician in Houston hospitals. Columbia's pilot is Rick Searfoss, and this will be the first trip in space for Rick. Our mission specialist number 4 is Dr. Shannon Lucid, obviously very relaxed this morning. This will be the 15th flight in space for Columbia, which was the very first space shuttle, originally launched on April 12th, 1981. And we have a live video shot of our 7 STS-58 crew members as they leave their crew quarters en route for the elevator. Our Director of Flight Crew Operations, David Leesma, and our T-38 and Shuttle Training Aircraft weather pilot, Jim Weatherby, accompanying the crew members. The crew being led out by Commander John Blaha and Dr. Ray Seddon, our payload commander.
OTC, OVCC. Last crew members boarding at this time. Copy.
Mission specialist number 4, Dr. Shannon Lucid, now entering the vehicle and becoming the 7th and final crew member aboard Columbia. T-minus 8 minutes and counting.
PLT, essential bus source fuel cell switches complete.
Copy.
T-minus 7 minutes, 30 seconds, and the ground launch sequencer has initiated retraction of the orbiter crew access arm away from Columbia. This bridge between the orbiter and the launch tower can be reinstalled back in place within 15 seconds if need be. T-minus 7 minutes, 10 seconds, and counting.
Countdown clock will resume on my mark. 3, 2, 1, mark. Okay, let's just go for orbiter APU start. Copy. PLT OTC, perform APU start.
APU starts and work.
Orbiter test conductor Brian Momborn has given our pilot Rick Searfoss the command to start Columbia's auxiliary power unit. Once the pilot completes this task, hydrazine will begin flowing into the holding tanks of the orbiter's auxiliary power units. 37 seconds before launch, the ground launch sequencer will make a final check to assure that the vent hood is positioned well away from the space shuttle.
Verify no unexpected errors.
Caution warning, memory clears and work.
Orbiter test conductor Brian Momborn requested pilot Rick Searfoss to clear the ship's caution and warning memory system.
OTC, PLT, caution and warning, memory clear, complete, no unexpected errors.
Retraction of the external tank's gaseous oxygen vent hood is now in work.
Close and lock your visors, initiate O2 flow. This time we're going to send you.
Roger that, closing visors, pseudo 2 on.
Orbiter test conductor Brian Momborn instructing the flight crew to close and lock their visors. T-minus 1 minute, 50 seconds, and counting. All systems remain go at T-minus 15 seconds.
10. Yeah, let's go for main engine start.
Set T-minus 6, 5, 4. We have main engine start. 3, 2, 1. Booster ignition and liftoff of Columbia on a life sciences mission for Earth and space.
Houston's now controlling.
Houston, Columbia, roll program.
Roger, roll, Columbia. Mission Control sees a good roll maneuver, placing Columbia on the proper heading. 3 good engines at 100%. Engines are throttling back now, easing Columbia through the dense lower altitudes, but continuing to accelerate very rapidly. Columbia is already traveling over 650 miles per hour. Columbia continues to climb at a relatively steep angle at this point, tripling its rate of speed over the next minute. Solid rocket boosters, each delivering 3.3 million pounds of thrust, will burn out and separate at 2 minutes 3 seconds. Time now 1 minute 48 seconds. SRB chamber pressure is tailing off. And Mission Control sees a good booster separation. Columbia is now flying free, powered by its own main engines. Second stage guidance is now in effect. Altitude 184,000 feet, downrange distance 35 nautical miles.
Columbia, Houston, performance nominal.
Roger, Kurt, performance nominal.
Copy 103 converged. Press to MECO.
Press. Columbia, Houston, press to MECO.
Press to MECO.
Single engine Ben Guerrier 104.
Columbia, Houston, single engine Ben Guerrier 104.
Booster, any changes for the dump?
Negative, flight. Or go for the dump. MECO +2.
Copy.
And joining David Wolf in the Space Lab module is payload commander for the STS-58 mission, Ray Seddon. She's primarily been the crew member in charge of activating all of the systems in the module in preparation for the crew to move into this area and begin science activities.
You getting on here next, Bill?
I was here for W1.
Well, you can get on here next.
Who's going to do it with
At
you?
some point, I've got to get to my cows of the mass measurement. I can't do it during this. I don't think I can.
Go.
Flight is great.
I'm ready.
comfortable to hold my head there, but you're right, I gotta look there.
Yeah. Larry, we're showing a noisy signal on the EMG up here, so we're going to try and troubleshoot a little bit.
We copy that, Ray. We'll help you if we can.
Also in the foreground, Mission Specialist Dave Wolf is completing his runs in the rotating chair, the second subject of the day for that experiment. First several runs are done where the chair is spun for about a minute, and then it stopped suddenly, and Wolf stays sitting up straight. Then runs are done with the chair spinning and then stops suddenly, and then Wolf will lean forward. Again, to test a reflex known as the vestibulo-ocular reflex, which is a series of rapid eye movements that allow us to see objects as we're in rapid motion, objects that are in rapid motion past us. It's one in the series of tests that study the sense of orientation and how it adapts to weightlessness.
This is KC5CKM calling the K5PXP from the Space Shuttle Columbia. Over. That's C2's got someone just blabbering.
C2 does. That in?
Yeah. And we're starting to pick you up on the Space Shuttle Columbia, K5PXP. How are you doing today?
Over. Over. It's good for kids.
Yeah. Okay, and I'm copying you about 4 by now. Over. Okay, I caught the first part that says, how does it feel, but you were cut out on the last. Say again. Well, I tell you what, it just feels great. Over. none of us on this crew had any real problems in the initial adaptation to weightlessness, and now our third day out, we're just having a ball up here. It's wonderful, like floating free. Over. Okay, what I copied was the type of work that we'll be doing to find out information and research for a space station in the future. This Space Lab flight is a 2-week mission, and we're doing life sciences research, and the bulk of the research that will be done on a space station will be intended to be long-duration life sciences research. So we're part of a continuum of that research to understand how humans adapt to space, with a lot of applications for Earth-type diseases and problems that are happening on the ground. Over.
This is Mission Control on our live television from Columbia's flight deck. Shuttle Commander John Blaha is talking on the Shuttle Amateur Radio experiment with a school in San Antonio, Texas. San Antonio is Blaha's hometown, and this school setup was arranged pre-flight for him to talk to students there.
There's some movement. I'm ready. You're slightly broken. Go ahead with your questions.
Did you get a beat on it, Ray?
Well, Steve, if you'd relay to Isaiah, my heart rate has gotten slightly higher, although it didn't change significantly.
Okay.
I found when I exercise up here, though, it is harder to get my heart rate up as high as I can on the ground because I'm doing so much less work. Over.
Okay, this is the flight deck here, and I'm showing you a parachute in the commander seat area. Then I'm showing you where we put our messages. Those are the failure impact workaround messages, our next primary landing site opportunities, and then the deorbit propellant tank data. That's the flight plan summary right there. This is the emergency oxygen mask. Each crew member has one of them. This unit here is the wireless communications unit. And here you see the RHC and the flight instruments that we use to monitor the vehicle and fly it. Here's the orbiter heads-up display, the CRTs, the keyboards that we use for entries into the computers. There's the autopilot here right underneath the flight plan. Our flight deck just has a heck of a lot of equipment on it, and this is a little pan of that so that everyone, those are the aft windows and the overhead windows and our comm equipment over on the far left side of the picture there. We're starting here on the port or left side of the mid-deck, and believe it or not, having one waste compartment has not been a problem for 7 people. We get through there just fine in the morning. One delta is that we have the urine monitoring system attached, and we take a sample of every urine void that we make. Transitioning on, you'll see once we take those samples, we take the sample containers and we move them over and put them in the enhanced orbiter refrigerator freezer, which is in the freezer mode right now, and it currently appears to be running pretty well. After we've taken care of those things, we're all interested in having breakfast. For each day, we put our breakfast tray out, our breakfast drawer, and we have a part of it has breakfast, then lunch, and dinner. We rehydrate the foods here, and then we can put anything that needs to be warmed down in the oven, and it warms up very nicely, and we have quite a tasty meal. But along with monitoring everything that goes out of our bodies, we're also monitoring everything that goes in, and we use this barcode reader to record all the food that we eat. All items are barcoded. Of course, trash is a big problem. problem, as you can imagine, so we have to take care of it. Here we're taking trash out of our trash compactor, and when it is full, we take it and move it to our waste trash volume in the floor. We store all sorts of equipment in these lockers: clothes, washcloths, towels, film, etc., everything you need to live. We receive our messages through this machine, a thermal imaging printing system, and Bill puts it all out in the morning. We store our launch and entry spacesuits behind this net. We store the lower body negative pressure system here while not in use.
Okay, here we are, Marty.
What's this coming up?
This is Korea. We're doing a mapping pass in Korea. I think this is Incheon we're coming over. We'll move the camera up.
Are you out of film?
Hold it there.
Battery dead? Check the battery.
Battery's good.
Marty, keep open
Turn manually? Oh, sorry. Turn manually?
South Korea, we're over.
Rick, we're coming inside to the camcorder.
Okay, let me get one more shot with the wide field of view viz of the entire area from Baja, California, up to the Salton Sea, then into Los Angeles, looking across the desert and all the way up the coast, and I'll be right with you. John's up here exercising, so it's a busy flight deck.
Copy that.
No, ma'am, we haven't yet performed the dissections. Those are scheduled for Flight Day 13. We've focused mainly on the hematology activities, which on human studies to look at the anemia of space. Early data in SOS-1 showed that a release of red blood cells from the bone marrow was not occurring normally. So we're now looking at red blood cell incorporation of iron and release from the bone marrow into the blood. Also doing animal studies that do those same analyses, and we'll understand the red blood cell kinetics and iron incorporation to a much greater extent. Now, Marty has something to add here. Yeah, this is one of the important things
sometimes you hear people talk about, the spiritual or effect it has on you, or personal feelings about how it affects your life later when you come back from being in space. I'm wondering, while I get to talk to someone out there, how do you feel right now about that? Do you think it'll affect you long term or no?
This is Mission Control Houston. We're about to lose contact with the shuttle Columbia through the tracking and data relay satellite system. We'll be losing this live downlink picture from the payload bay cameras. Columbia now passing over the southern portion of the Caspian Sea on this 12th orbit of the Earth at an altitude of 156 nautical miles. All systems aboard the shuttle continue to work well as the crew is in its sleep shift, scheduled to awaken about 2.5 hours from now.
This is Mission Control Houston. Columbia is just crossing the west coast of the United States, up just north of San Francisco in the Oakland area. Columbia moving across Death Valley. This is the 68th orbit of Columbia's STS-58 mission. Lake Mead just coming into view, which is the border of Nevada and Utah, as well as Arizona. And the Grand Canyon just moving out of the picture up to the upper left. This pass of Columbia across the United States should take the orbiter over most of Arizona, New Mexico, and a large portion of Texas before moving out across the Gulf of Mexico. And Columbia just passing high above Lubbock, Texas, the gray area in this left center portion of the screen. Columbia is making a swing across Texas from the northwest to southeast. And the Dallas-Fort Worth area just coming into view from the lower right-hand portion of the screen. And Lake Livingston, which is in the northwest portions of Houston, up near Huntsville.
This is Spacelab Mission Operations Control. Columbia is now coming up on the southern coast of Australia. The island over towards the right-hand portion of this particular downlink view is Kangaroo Island. This is the area near Adelaide, Australia. The large cluster of lights that is towards, moving into the center of the screen right at this moment is the city of Adelaide.
Larry, that was really beautiful, and we just want to tell you how much we've enjoyed working with all of you. You've sure been a help and a comfort to know that you're there, monitoring our systems, helping us, watching us, getting us through the difficult spots. And we really appreciate all the hard work that people put into getting us up here and getting all the equipment ready, putting the procedures and the time.
Columbia.
Ryan and Shannon. Good. Think what they're gonna smell like.
Pull the suit down so I can show all the bags over there.
Sure.
Eight at 120. 7 at 100. 5 at 90. 6 at 80. 6 at 70.
No.
Shoot's coming. Shoot's coming.
Okay.
At 58 knots.
You know what I'm doing?
Yeah, okay.
I mean, I know why.
Yeah.
For the 19 good.
Yeah, understand. 20 knots. 10 knots.
There goes the STS. Houston,
Wheel stop.
Columbia is wheel stop. Good work, Rick, Bill, everybody.
Columbia Houston, we see you go for the PTIs.
Roger, go for the PTI.
The PTI is a program test input. This will be a firing of about 10 seconds in duration of 2 reaction control systems jets on either side of the nose of the orbiter. Range from the landing site is now 68 nautical miles. Columbia's speed is 1,900 miles per hour. Switching to a long-range camera from the Dryden Flight Research Facility. Columbia's altitude is 40,000 feet. The twin sonic booms of the orbiter are announcing the arrival in the landing area. Commander John Blaha is now flying the vehicle, having taken over for the software. He begins the wide left overhead turn to set up on final approach to runway 22. Time to touchdown, 1 minute, 45 seconds.
Columbia Houston, we show you on glide slope, on center line, surface winds are 350 at 1 to 2 knots.
Columbia's altitude is about 6,000 feet. Commander will shortly raise the nose of the orbiter to slow the descent. And the pilot will lower the landing gear at about 400 feet. The landing gear is now down. Main gear touchdown. And nose gear touchdown. Columbia is rolling out on runway 22 at Edwards Air Force Base, traveling 5,840,000 miles and completing 14 days in space, which makes the STS-58 mission the longest flight in the shuttle program.
Houston, Columbia is wheel stop.
Columbia Houston, we copy wheel stops, and congratulations on a very successful life sciences mission, and also for being the fourth longest mission in our space program history.
Roger that, Kurt. And from the entire crew, we sure appreciate all the help we got on this mission from everybody on the ground.
John, we copy, and we're proud to be a part of it. We have no post-landing deltas at this time, and you're go to proceed.
Roger, Convoy Commander, this is Columbia. Read you loud and clear.
Columbia Houston, good morning. We know you're out there somewhere.
Good morning, Greg. How you doing?
Got you loud and clear. It's Charlie, and Orbit 3's here with you.
Oh, I tell you, Charlie, y'all are good this morning, Greg. To the music, buddy.
We're hoping you're having a good day.
Oh, it's wonderful. Thank you. As I'm sure you can appreciate, this lab is an awful lot of fun.
Roger that.
Well, good morning, Houston. It must be Halloween down there on Sunday morning.
Columbia Houston, good morning, John. Trick or treat.
Top of the morning to you, Charlie.
Same to you, John. Happy Halloween.
Columbia for John, we are forecasting that the temperature will be in the mid-40s at your landing time at Edwards.
Okay, well, that's useful information. Thank you. And do you have any kind of forecast on the weather at all and the surface winds at that time?
John, we're going to tip you up that message shortly so that you have the complete information.
Okay, thanks.
On glide slope and center line.
Copy glide slope and center line.
Columbia, Houston, we show you on glide slope on center line. Surface winds are 350 at 1 to 2 knots.
Okay, stand by all operators for post-landing deltas. Okay, post-landing deltas max.
No deltas flight.
Pop.
No deltas flight.
None.
Columbia, Houston, we copy wheel stops, and congratulations on a very successful life sciences mission, and also for being the
GPS
fourth longest
deltas.
mission in our space program history.
Inco.
No deltas.
Roger that, Kurt.
Booster.
And from the
No
entire
deltas flight.
crew, we
Payload.
sure appreciate all the help
FAO.
we got
No
on
deltas.
this mission from everybody on the
DPS
ground.
post-landing deltas.
None flight.
No post-landing deltas. Proceed with nominal operations.
John, we copy, and we're proud to be a part of it. We have no post-landing deltas at this time, and you're go to proceed.
Inco, let me know when you've commanded the uppers.
Roger, convoy commander, this is Columbia. Huntsville Space Lab, we're with you. We're ready to begin another day of research. We're all set up to do the animals in the aft of the laboratory and waiting for your words to begin.
Huntsville Space Lab, good morning. Look forward to another good day. Space Lab, Huntsville, go ahead.
Yeah, I think we're done with the echoes on Rick. I tried the tilt crane several times and my arm was getting tired, but I think that last one looked good. And so he's heading back up to the front.
Yeah, the ground liked the echo that you did on Rick. They're really very pleased with it, and thank both of you for that extra effort.
Thank you, and we'll pass that on to Rick.
Good morning, Ray. This is APS from SLS-1. How are you today?
Oh, that's a nice, familiar voice. Marty and I are standing here smiling at each other. Hi, Bob.
All right. How are things going for both of you?
Just fantastic, Bob. This is like the greatest thing I've ever done. We are having a fun time and getting a hell of a lot of work done. I hope you're having fun watching us.
Absolutely. I surely am, and I'm delighted to be back down here for a few days at the POC, and glad I have a chance to talk to you this morning.
Good to hear from you, Bob, and thanks for helping me get up here.
You're most welcome, and behave yourselves on Halloween.